Okay, so what have we got there, Jake?
A mechanism?
It is a really good example of a mechanism, a screw mechanism. Okay, so you can see the two gears, the worm gear there and the little spur gear there. So this is a little ukulele, isn't it? You play this all the time, don't you, Jake? I like that. Great little instrument, that. Okay, and what other instruments can we show them that relate to mechanisms in some way, even air mechanisms?
Well, we got the not bearing. I mean, a recorder.
Yeah, the recorder's a pneumatic mechanism, isn't it, really? Very clever. I can't really play this. I used to when I was younger. I'm sure you can, though. But anyway, that's a pneumatic mechanism. And the input is when you're blowing, and the control, the output, is obviously the sound and how you move your hands. Great, okay, so this is part 2 of mechanisms, and we wanted you to perhaps view some of our research. Jake's done some quite clever notes here with my daughter, and we'll go through these notes later, but I think to start with I'll show you some of the best books I've been using, and this is a range of them. These are two very good books. My father wrote these many years ago, this one in particular with a friend, and this really does show a very good set of notes and using diagrams on how mechanisms can be shown in pictures. And here you can see the various levers and the arrangements of levers in relation to the fulcrum, the pivot point, and the load. The load's the piece you're actually moving. In this case, the effort is the person pulling up, pushing down on the lever, and the fulcrum's the pivot point, pulling up that pallet of wood there, or bricks, whatever it is. And there are 3 different lever types, 3 classes of lever, which we'll talk about. But this book's been really useful to me actually over the years, and it shows linkages here and how linkages can be used to gain a really accurate, precise mechanisms to work. And then this one here on pulleys. Now pulleys are used in all sorts of things. Sometimes they're hidden, but you often see them for lifting in construction site situations, and perhaps in a warehouse where they're lifting large loads. And it allows you to lift with relatively low effort from a human point of view, large loads, okay, very heavy loads. And this one here shows a bevel gear and a pulley on it. We've seen that in our drill. Jake?
Yeah, so would the pulley be on the electric drill?
Yes, it is. We'll actually go back to that. So, Shedhackers, have a look at this. So, I'm glad you said that. Here's the mini pillar drill, and we're looking at pulleys and in sense ratios. And you can see the power's produced by the motor. And we have a set of pulley wheels here, and a second set of pulley wheels here. They're connected with the belt, the pulley belt. And Jake, I've got to get this right because it's quite confusing at times. So when the motor's turned on, if the pulley's on a low, a smaller diameter wheel, driving a larger one, that will mean it's going slowly.
Yes.
If this pulley's put on the top one there, the larger diameter pulley wheel, and it's connected to the smaller pulley wheel here, the output, the chuck here, will be spinning at high speed. And I did have a note on ratios, but the ratios, oh, here they are. They're the ratios. Can you get those? So you can see the ratio changes and the speed changes. Look, the speed changes. Yeah, look, 500 and what's that say?
520.
Yeah.
To 900 to 30.
Yeah.
And
so it's
170.
the ratios. It really makes a difference on machinery. What you can have high speed but low power. That's you tend to lose something. So you get speed, but you don't actually get what we call torque, which is the power to stop it turning. Yes, Jake.
So then how does the drill bit go up and down with this?
Well, I'm glad you asked that, because this is a really good example of a rack and pinion. So if I move that down, if you come round, Jake, can you see that rack? I'm just going to move that handle there. There's the rack there. Can you see that?
Yeah.
And I hope the viewers can see that. So there's the rack, and the pinion's connected to this piece of metal or this spindle behind here. So there'd be a gear which connects there. Good question, that. Okay, so moving across to our research. There was something there on cams, and a cam is an odd-shaped eccentric wheel. Sometimes looking like an egg-shaped wheel, and I've really struggled to find things with cams in, but in this book here it does show actually a really good example, okay, of mechanisms. There's rack and pinion on the car, the steering on the car, and here's a universal joint. It's called Hooke's joint, where you can have a rotary motion connecting to a rotary motion, but you can actually change the angle of it, and you get that on a lorry there where it's driving the back wheels, but actually the drive shaft has to be at a slight angle. And then I think that's what I wanted to show you, but a really good book that, so thanks to my dad for writing that book. And there's a lot of mathematics that goes into all of this, which he talks about later on. And we'll actually talk about it because it talks about mechanical advantage, okay? And I think in this book, the guide to the other book, it talks about the science behind the gears and the ratios. Here's the cam again. Look, you get different types of cam, and cams can obviously be on a cylinder, so the cylinder actual shape can change. They're really clever, really clever. Yes, Jake.
Oh,
There's the escapement from the clock, which rocks from side to side to regulate the timing of the gears. So this book's really quite clever. The structures it goes into as well. Remember that when I was a little boy, little lorry I had. Okay, so that's that. Now we're going to look at the types of movement quickly, and we'll look at this calculation in a minute. A mechanism creates movement within a product. Okay, the product is usually to help humans, but it can be to help animals as well. And perhaps we'll think of some as we get through this dialogue in a minute. So the types of movement there, Jake, can you see that? Got rotating. Yeah. Rotating is turning motion, isn't it? Turning, like a clock hands. Linear, motion in one direction, okay, usually in a straight line. Reciprocal or reciprocating, like a sewing machine head, so it could be that way or it could be that way, up and down. Can you think of something like that?
Would it be like this weighing scale here, because you like push down on it and it goes
well,
up and
that's
down.
Reciprocating up and down, but the actual output is rotary, isn't it? The dial is moving, but inside there will be quite a clever, precise mechanism, so it can actually make that change really quite precisely. Look. Wow. Okay, so yes, that's a good question. Oscillating is like the pendulum on the clock, so if you just scan in there, Jake. Yeah. So they're the four types Jake will just show you there. Okay, and then we're going to look at now briefly the types of levers. And this is class 1. Now we're not going to spend too long on this because I've got a diagram Jake's done for me. But that's class 1, and it matters where the load is in relation to the pivot point called the fulcrum and the effort here. Okay, so that's class 1 there, and scissors is a good example of class 1. Then moving on here, Jake, to class 2. This is, I think, sometimes hard for you to understand, but you can see the efforts on the end, the loads towards the other end, and the fulcrums towards the middle, and it can vary. And that's, I suppose, more like the seesaws you may play in the playground or have played on when you're younger, if you're very young. And then that's class 2. Quite hard to follow this, really, I think. And then class 3 is when the fulcrum's towards the end here, and the efforts in between the fulcrum and the load. So that's hard to explain that. Yes, Jake.
So would that be like some sort of spade kind of?
Well, going back to this book here, I suppose the nearest one to that, if you get on there, yes, is like a spade. So you're holding it against your body here, you're pulling it up with your hand, and the load is the mud on the end, if you can see that, guys. And they've tried to show it in a human body. It mentions tweezers, the human ard, and a fishing rod or a spade. those that do fishing. And then go back to second order or second type. It mentions, there you go, the wheelbarrow with the load in the middle, the pivot points, the wheel pin or axle, and the effort is you lifting it up. There, look.
Wow.
There are your willy boots. And there's this sort of system, the diagram for it, schematic I think they call it. And then type 1, they call it first order in this book, efforts there, that's the seesaw. That's interesting, that's the seesaw. So I think if we can remember it that way. Okay, I think I mentioned seesaw's type 2, so it's not, it's type 1. Okay, but it mentions scissors, a seesaw and a crowbar for type 1. Okay, but focus on that, guys, and maybe we can get some notes from that later. Okay, so moving to the next part. Now let's just focus on the types. We've got the types of mechanisms here. The spur gear. You can have many gears joined together, and that's called a gear train. And you may see that in a gearbox in a car or something like that. That's a train of gears when you have more than 2. The rack and pinion we've talked about already, Jake. Yes, Jake.
So with the gear train, on a bike they would normally call it the drivetrain, or on a car.
I suppose
Is that where
so.
it comes from?
Yes, I suppose so. Yes, you're right. Yeah, be something along those lines. A crank here, which is, we tried to show it here, didn't we, Jake? The crank, this part here, where the pin here is slightly offset from the centre. Yeah, it's normally on a slight lever there. Okay, hard to explain sometimes, but a crank handle, yes, sometimes in the old cars you'd crank them over with a big crank handle. Pulleys, we talked about pulleys on the pillar drill, and the linkages. Linkages, well, here's a sort of a toy I made many years ago, and it shows linkages in some way with connections with the string there. Little man, look, is that you, Jake, do you think?
No, I think
That's
it's
clever,
you.
that. So that's a few years old, that. Okay. I made that when I think I was 9 years old. Look at that. Clever, that. Right, so we've looked at spur gears, which we mentioned here. Oh, the worm gear. Worm gear. We saw that somewhere. Where did we see them? Oh, on the ukulele. I'll just go and get the ukulele again. There we go. There's the there. Is that there? Yeah, worm gear.
So it's like a screw turning a gear.
I'm getting carried away again. Right, yeah, sort of is. Yeah, there's the cam and follow. It's hard. We saw that on the drill, and I'll just get the drill again. There's the drill, the bevel gear. Yeah, guys. 45-degree change, can vary. With the pulleys, crank, the linkage we've mentioned, and that yes, leave there, and the scissors. The chain we talked about on your bicycle, haven't we?
Yep.
Yeah, bicycle chain. And the ratio changes you can have. All these can have ratio changes. That means the input speed can be different from the output speed. Okay, to make the job easier. A mechanism isn't designed to make a job harder. It's always designed to make a job easier. Okay. And pneumatics. I don't know why they don't mention hydraulics, actually, which is using fluid, because it is to do with mechanisms. And one area I think the viewers could look into, hydraulics, but pneumatics is about the use of air pressure. Okay, and we talked about the bicycle pump on that one. But yeah, hydraulics, I think, which is uses fluid, doesn't it, Jake?
Yeah.
In fact, your bicycle has hydraulic brakes, doesn't it? Quite expensive brakes. So moving on a little bit, and we're finished on these points, so we don't make things too confusing for you. Here's some notes from my daughter, or one of my daughters. And here's some notes about levers. So there's the classes, guys. So Jake, if you pan on, so class 1, there you go. Class 2 and class 3, good. And then we talk about mechanical advantage now. Jake, talk to me a little bit about mechanical advantage in relation to friction. There's a little note there.
Well, is mechanical advantage to make something essentially easier for the operator?
Good, excellent. Okay, here's an example. So pan back a bit. This little G-clamp, it has a small movement here because the thread's actually quite fine. But I've got a lever on it, which makes that easier. So when I tighten something, if there was something in there, the mechanical advantage is that distance there. So a large movement there is only a small movement here. And there's the ratio, so it's a step-down ratio. And that makes me tighten that really as tight as I can, perhaps crushing two bits of wood together. Jake?
So then what would an umbrella be? What kind of mechanism would that be?
You saw that on the floor, didn't you?
Yeah.
I've been hiding it from you. So this umbrella is, I suppose, I don't know, it's a linkage, I suppose, of some sort. Clever that, with the pins, little pins there, look. As you can see, the little pins there, hidden. There, little pin. Yeah. Okay, brilliant. Good question. You saw that. I saw that earlier. So if you're calculating for load, you multiply mechanical advantage by effort. There. If you're calculating for mechanical advantage, you divide load by the effort. There. And if you're calculating for effort, Jake, you divide load by mechanical advantage. Yeah?
Mm-hmm.
Is that right?
Yeah, that's about right.
And here are the calculations, and I've written them out. In fact, you did that, Jake. Well done. Well done. Now, you talked about friction and what part friction has to play in things. Friction really can be a good thing or a really negative thing. In most cases, it's not a great thing, but where things aren't 100% efficient, so that means you haven't got exactly the same power you're putting into the same power you're getting out from the mechanism. You have losses in energy, I suppose, and that's usually down to friction. So it could be where things are rubbing or getting hot. Any other ideas, Jake?
So is there like friction on an aeroplane when it's going through the sky?
Yes, there's wind, air friction.
Wow.
Wind resistance, they call it. And actually the resistance in an aeroplane also allows it to fly because it causes elevation through the aerofoil shape on the wing. So that's a really good example of where it's useful to have some sort of resistance. But there's a negative as well. That's why the actual cabin part, the fuselage part, is very thin, like a bullet, or shaped like a bullet. Right, so any other questions? Oh, there's this. What's that used for, Jake?
It looks like some car bearing or something.
It is a bearing, I think, off a large machine, possibly even a lorry. And why do we use little bearings like that? There's bearings behind this cage.
Well, I wouldn't say it's little, but would it be to reduce friction and wear on the
Yes,
car?
that's exactly what it does. Spindle, all the axle goes in there, and this is held firmly on the outside. So you haven't got the heat being generated by the axle moving in a hole. Okay.
But then, of course, you do need to keep the balls inside lubricated.
Yeah, they're sort of hidden behind there. There's a little ball bearing. You just see it shining there, hidden behind this casing. Yes, you're right. It has to use oil or grease, don't you? And that helps to reduce friction even more. So yeah, mechanisms often have to be lubricated as well as them being carefully designed. Okay, any questions, Jake? Any questions at all?
I don't think so.
I think we've covered on friction. Well, I hope you've really enjoyed that, guys. And that's part 2 of mechanisms. But, you know, I think all these things can be quite useful as you get older. And it helps you know what you're buying and why things are wearing. And perhaps why things need repairing from time to time. And thank you to my dad for his kind lending of the book. Brilliant. Thanks. Okay, see you, Shed Hackers.